right, hi there. If you want to know how to write an abstract for a paper or conference paper in about 20 minutes, this video is for you. I know a lot of you are struggling with how to write an abstract or write it fast. And so we will talk about what an abstract is, the biggest writing mistakes, what should go into an abstract. So we're going to look at a couple of examples, and then how to write an abstract for a scientific article the easy way. Hi there, this is Julia from Grad Skills Pro, and so let's dive right into it. So first, what is an abstract, what it is not, and the biggest mistake that you can make when writing an abstract. An abstract appears at the beginning of a research article or a conference paper, and it's really the second most important part of the entire paper after the title, because the title actually grabs the attention of the reader, and the abstract is supposed to entice them to actually want to read the paper. So what the abstract is not just a summary. So a lot of people just summarize the paper and that's it, but this is not what an abstract is supposed to be about. The abstract is supposed to be similar to a summary, but entice the reader to actually want to know more. If you're telling people the biggest points of your paper, then they might not actually want to read the paper because they feel like they already know enough from the abstract. So what should go into an abstract? And so we're going to look at a few examples over here.
So this is the first example of a paper that was published a few years ago in PLOS Computational Biology. This is what I would call a community paper. It actually went out as a review, and I talk about this in a lot more detail in my course, the Zero-To-Published program. And so this is the full abstract. I'm not sure what the word limit for this one is. It doesn't even matter because the structure is all basically the same. So the first few sentences are the problem and the state of the field, or the problem statement. So here we talk about many scientific disciplines rely on computational methods for data analysis, model generation, prediction. Implementing these methods is often accomplished by researchers with domain expertise, but without formal training in software engineering or computer science. This arrangement has led to an underappreciation of sustainability and maintainability of scientific software tools developed in academic environments. So this really leads into the problem. Then the second part is, here we fix this by doing X, right? So how are you going to contribute to the solution of this problem? So here, this is actually two sentences. It says, some software tools have avoided this fate, including the scientific library Rosetta. We use this software in its community as a case study to show how modern software development can be accomplished successfully, irrespective of subject area. Then after you talk about how you are going to contribute to the solution of this problem, I usually talk about 3 or 4 catchy things that entice the reader to want to know more. And it might be more than 3 things, but usually the human brain is very good at remembering 3 things. And it can be a little more if you have more space, but don't talk about 50 new things or just 1. So you want to give a little bit of a deeper introduction here. And here, as an example, Rosetta is one of the largest software suites for macromolecular modeling with 3.1 million lines of code and many state-of-the-art applications. Since the mid-1990s, the software has been developed collaboratively by the Rosetta Commons, a community of academics from over 60 institutions worldwide with diverse backgrounds including chemistry, biology, physiology, physics, engineering, mathematics, and computer science. Developing the software suite has provided us with more than 2 decades of experience in how to effectively develop advanced scientific software in a global community with hundreds of contributors. Here we illustrate the functioning of this development community by addressing technical aspects like version control, testing and maintenance, community building strategies, diversity efforts, software dissemination, and user support. So these are a few more than 3 catchy things, but we really introduce the Rosetta software suite, the Rosetta Commons, and what we really talk about in this paper. If you want to drill this down to 3 catchy things, it's basically the introduction of Rosetta. We have diverse backgrounds. This is what our community looks like. We have more than 2 decades of experience. And then we talk about a lot of these aspects in this paper, such as technical aspects, community building strategies, diversity efforts, software dissemination, and user support. And so there's a lot of bits and pieces here. And this is in 4 sentences. This gives us a pretty good overview of what this paper is about. And the last part of the abstract is the application. How does this make the world a better place? And here in this example, we say, we demonstrate how modern computational research can thrive in a distributed collaborative community. The practices described here are independent of subject area and can be readily adopted by other software development communities. So this is the abstract for this particular paper. It's a little bit on the longer side. And if you read this abstract, what are the points that are made here? What are the lessons that we have learned in the last 20 years that really any community can use? And this really entices the reader to want to know more and actually dive into the paper. So that's the first example. Let's look at another example. This is a method development paper for structure-based protein function prediction using graph convolutional networks, which was published in Nature Communications. And the overall structure of the abstract is exactly the same. The state of the field and the problem statement. The rapid increase in the number of proteins and sequence databases and the diversity of their functions challenge computational approaches for automated function prediction. And this is a way to say automated function prediction cannot be easily done simply because the growth of the protein sequences that are known is larger than what we can handle. So then the second part here in yellow is, here we fix this by doing X. So what do? What's our contribution here? Here we introduce DeepFry, a graph convolutional network for predicting protein functions by leveraging sequence features extracted from a protein language model and protein structures. And so we basically say, hey, we have a cool method for predicting protein function. So now we talk about, in the blue part, the 3 catchy things. So DeepFry outperforms current leading methods in sequence-based convolutional neural networks and scales to the size of current sequence repositories. So basically already says, oh, we fixed the problem that we've talked about in the first sentence. Hey, this is cool. The next thing is, augmenting the training set of experimental structures with homology models allows us to significantly expand the number of predictable functions. DeepFry has significant denoising capability with only a minor drop in performance when experimental structures are replaced by protein models. Class activation mapping allows function predictions at an unprecedented resolution, allowing site-specific annotations at the residue level in an automated manner. So it really tells you all the cool things that it does, and by reading this, you definitely want to read the rest of the paper to see how this is actually done. So the last part here is, how does this make the world a better place? We show the utility and high performance of our method by annotating structures from the PDB and Swiss model, making several new confident function predictions. DeepFry is available as a web server at, and so on. Again, this is the same overall structure as an abstract should look like.
There we go. So let's try this again.
So let's look at the last example. This is also a method development paper, but it doesn't matter whether you're talking about a hypothesis-driven paper, a review paper, a method development paper, or database paper. The framework for the abstract is exactly the same. This was published in Nature Communications, and again, the same thing. First, we talk about the state of the field and the problem statement. Each year, vast international resources are wasted on irreproducible research. The scientific community has been slow to adapt standard software engineering practices despite the increases in high-dimensional data, complexities of workflows, and computational environments. So this introduces the problem and the field. Then in yellow, what are we doing about this? Here we show how scientific software applications can be created in a reproducible manner when simple design goals for reproducibility are met. Aha, now that is interesting, right? So we want to know more. So now we talk about the 3 catchy things. We describe the implementation of a test server framework and 40 scientific benchmarks covering numerous applications in Rosetta bio-macromolecular modeling. High-performance computing cluster integration allows these benchmarks to run continuously and automatically. Detailed protocol captures are useful for developers and users of Rosetta and other macromolecular modeling tools. So these are all the cool things that we're going to talk about in this paper. And so you want to know, what are the design goals? How is the test server framework set up? What kind of scientific benchmarks are you talking about? Can I use this stuff for my own research? Can I use those protocol captures and run my own models? And these 3 catchy things are supposed to entice the reader to want to know more and actually want to dive into the paper. Now, lastly, how does this make the world a better place? The framework and design concepts presented here are valuable for developers and users of any type of scientific software and for the scientific community to create reproducible methods. Specific examples highlight the utility of this framework, and the comprehensive documentation illustrates the ease of adding new tests in a matter of hours. So it makes the world a better place by presenting a resource for developers and users, not just of the specific Rosetta software that we're talking about, but for any type of scientific software, and allows them to create reproducible methods. And the paper goes through specific examples and gives documentation how anybody can add scientific tests in a matter of hours. It's the same structure of the abstract as I've shown in these 3 examples. Obviously, the details differ, which is why your abstract is going to be different.
And now the question is how to write an abstract for a scientific article the easy way. So first, you need to know what your constraints are. Usually there's a word limit. It depends on the journal. It depends on the conference. They give you a word limit. So it can be anywhere from 150 words, 200 words, 250 words, 300 words. And so you need to know how much you're allowed to write. And then you write things down. When you start writing, I highly recommend starting with bullet points so you can easily move them around and you can actually make the overall story of the abstract flow. And once you're happy with the flow, turn them into sentences, add connectors between the sentences. The first thing that you're going to write down is the problem and the state of the field. So really like 1 to 2 sentences, just get into what the general problem is. The second point is, as we've seen in those examples, is introduce your method or your research problem that you're trying to solve. This is how you're responding to the problem statement in the first 1 or 2 sentences by introducing what you are going to do about it. And so that introduction could really be done ideally in 1 sentence. Then talk about 3 catchy things. So you want to talk about 3 things that are great about how you solved a specific problem, 3 great findings, 3 ways of why the method you have developed is very cool. And so you should talk about the what and not necessarily the how. And this can be done in about 3 to 4 sentences, depending on how much space you have. And then last but not least, how does this make the world a better place? How can this be applied? What is it useful for? Who does it help? And so that last part can be done in 1 to 2 sentences, again, depending on how much space you have. Once you know what goes into it, these are the steps you need to follow, and then remove the jargon. So you want to make sure that it's not just people in your field that can understand the abstract, but also people that are adjacent to your field. For rephrasing, you can also use tools like Grammarly, there's Quillbot, or you could even use ChatGPT if you are trying to make the sentence structure a little bit better. So these are tools that are available to you. And then remove unnecessary words to trim it down to the word limit that you were given. If you would like to see more resources when it comes to writing your paper, you can see the description below. And that's basically it. Thank you so much for watching, and I will see you in my next video.